So what is the reason behind the elimination reaction? Why does the elimination reaction take place? So you can say that is driving force for elimination reaction. So basically there are two driving forces behind the elimination reaction. First is to relieve strain in the molecule. Second is to increase entropy of the reaction. So these are basically two driving forces behind the elimination reaction. What is the first one? To relieve strain in the molecule. The molecule strain decrease karibo. Okay. Second, entropy positive. Entropy increase means positive. Now we can take one example. Suppose you are taking haloalkane, CH3, CH2Cl in the presence of base alcoholic OH, it will be converted to alkene along with HCl. So this is the net reaction, right? And first, to relieve strain in the molecule. You will see in the first one, in haloalkane, what is the approximate bond angle? Approximate bond angle is 109 degree. Approximate bond angle 109 degree. Okay, tetrahedral. So you can take the approximate bond angle is 109 degree. And what is the bond angle in alkene? It is approximately 120 degree. Okay. So the bond angle in alkene is approximately 120 degree. So bond angle increases. Yes or no? After elimination reaction, bond angle increases. Due to the increase in bond angle increase, atoms or molecules will move away from each other. So the atom molecule move away kariwe, so the repulsion steric crowding steric crowding decreases. Okay, steric crowding decreases. Then steric crowding decrease over, stability of the molecule will be increased. Yes or no? Stability of the molecule will be increased. So first to relieve strain in the molecule. This is the first. Second, what is the second? To increase entropy in the molecule. So the reaction rate, above reaction rate, how many moles of reactants are there? 1 mole reactant, that is converted to 2 moles of the product. 1 mole reactant is converted to 2 moles of the product. So now number of moles increases. Since number of moles increases, then what will happen? Entropy is positive. Number of mole increase, entropy positive. The entropy positive habo. Okay, we can follow the Gibbs equation. Gibbs equation is delta G equal to delta H minus T delta S. So entropy is delta S. With the increase in the value of entropy, delta S, T delta S will be higher. So if T delta S will be higher, then what will happen? Delta G becomes negative. I mean, then say, the reaction rate, the entropy negative, sorry, the gives free energy negative way. If it gives free energy negative way, then what will happen? Due with the negative value of the gives free energy, the reaction becomes spontaneous. The reaction becomes spontaneous. Okay, students. So first is to relieve strain in the molecule with the increase in bond angle after elimination reaction. Second, to increase entropy of the reaction. So entropy increase hলে delta G negative হবে, delta G negative hলে reaction spontaneous হবে. So these are the two driving forces behind the elimination reaction. Halo alkane chapter रे ଆମେ କଣ ଦେଖିବା? ଯେମିତି କହିଲେ halo alkane undergo elimination in the presence of the base such as alcoholic OH to form alkene along with hydrogen halide. Alkene along with hydrogen halide. So this is the elimination reaction. Now we are going to discuss types of elimination reaction. Types of elimination reaction. So types re first is E1, second E2. ଏଥିରେ ତମ board syllabus ରେ ଅଛି. And one more we are going to discuss E1CB. Okay, E1CB. So what is E1? Elimination unimolecular. This is elimination bimolecular. It is elimination E1CB. Write on the full form. Unimolecular in conjugate base. Elimination unimolecular in conjugate base. Write on the full form. Then we'll discuss them one by one. Writing, student. So first one is E1 reaction. Elimination unimolecular reaction. We have already discussed SN1. So we will compare between E1 and SN1. Then there are many similarities between E1 and SN1. Similarity kono na reaction path or reaction mechanism. In SN1, the intermediate is carbocation. In E1, the intermediate is also carbocation. Okay. So both the E1 and SN1 reactions are going through the formation of carbocation intermediate. I'll देखिए mechanism. Step 1. Okay. Mechanism step 1. In the presence of polar protic solvent release of halide. Student note down. Takes place to form carbocation. In the presence of polar protic solvent, release of halide takes place to form carbocation intermediate. Halide you can write as X. Polar protic solvent. Okay. This is slow step and hence rate determining step. This is slow step and hence rate determining step. Student mechanism discuss kala pore we will discuss some questions. Note down. Now, step 2. We know in any reaction, again repeating, in any reaction, if carbocation is formed as the intermediate, then before giving the product, it may undergo rearrangement to form more stable carbocation. जो भी reaction हो, जो उतरे भी carbocation intermediate बनिबो, सेठी rearrange हवार scope अछि. Rearrangement of carbocation may take place to a more stable carbocation. Okay. Rearrangement of carbocation may take place. Okay, it is not always necessary, but may take place to form more stable carbocation. It is the second step. Now, third step, a release of hydrogen or its isotope from the adjacent carbon of stable carbocation center takes place to form alkene by following Sedgwick rule. Okay, by following Sedgwick rule. Note down release of hydrogen or its isotope from the adjacent carbon of stable carbocation center takes place to form alkene by following Sedgwick rule. So I hope all of you to remember Sedgwick rule. Sedgwick rule tells about the stability of alkene. Kemti, the more the number of hyperconjugative hydrogen present across double bonded carbon, more is the stability of alkene. Or in other words, more the number of alkyl groups, more is the stability of alkene. Okay, more is the stability of alkene. Note down, student. I hope all of you are writing. Note down. Okay, students, written. Now we are going to discuss one or two questions. I'm giving one or two questions. Here, I'm the questions. This is first question. Okay, student, try these two questions. Take 2 minutes. Who is students? I hope all of you are trying. Who is students? And the hint is, in both the cases, carbocation rearrangement will take place. जो भूल जाए carbocation rearrangement, no need to be panic. I will discuss it once again. So if anyone has completed, raise your hand or write in the chat box. Okay, I know it will take some time. Try. After writing, chat box complete कल chat box write yes or completed. The first question, कितने student complete कल? Write in the chat box. First question. Anyone? No. Okay, take some more time. No problem. Quick. Quick students. Okay, now we are going to discuss the first one. First, in the step one, by the action of polar protic solvent, the carbocation is this. Okay. Next, rearrangement of the carbocation. How? Now by methyl shift. This methyl group will be shifted. Now this is the carbocation, stable carbocation. Then third step, release of hydrogen. Then आपको एमती लिखिबा C plus C CH3H CH3. Now the hydrogen can be released from left side or from right side. Right side go to this one. Okay. So if that hydrogen is released in the form of H plus, then what will be formed? Alkene will be formed. So this is the alkene. And this alkene is stabilized by Sedgwick rule. Because if you compare or if you see how many hyperconjugated hydrogen atoms are present, 12 or 4 alkyl groups are present across double bonded carbon. The student quickly the one complete karna thilo, note down. Then we'll discuss the second question. Okay, completed. Now, second question. By the action of polar protic solvent, bromide will be released. Okay. Bromide will be released. So this is the carbocation. ଆପଣ ଜାଣିଛ ring ର alpha position ରେ ଯଦି ଗୋଟେ carbocation center ବନିବ, again repeating, if at the alpha position of the ring carbocation center is formed, then it may undergo rearrangement to form more stable carbocation. ତାହେଲେ ଏଠି rearrangement କ'ଣ ହବ? Ring expansion. Okay. So 1, 2, 3, 4, 5 and 6. So now 6-membered ring is formed. You can put the numbering with carbon number 1. One methyl group is present, and with carbon number 2, positive charge is there. Okay. Next, after this, again one more rearrangement is possible. That is, it would hydrogen achi. So hydride shift. In hydride shift, this, then after this, hydrogen release, hydrogen is released. This is the alkene. Student, quickly note down. This is the alkene. ଯଦି ଏ क्वेश्चन ତମେ ବୁଝି ପାରିଲ ସଲ୍ଭ କରି ପାରିଲ ଦେନ୍ ବାକି ତମର ବୋର୍ଡ ଲେଭେଲରେ ସ୍କୁଲ ଲେଭେଲରେ ଇଜି क्वेश्चन ଆସିବ ଓକେ ସୋ ଯୋଉମାନେ ନ ଲେଖି ପାରୁଛ କ୍ୱିକଲି ଆଉ ଥରେ ନୋଟ୍ କରିଦିଅ ଡନ୍ next is E2 reaction ଯେମିତି ଆମେ ଦେଖିଥିଲେ in E1 in the rate determining step in the slow step or rate determining step what is present now rate is proportional to haloalkane because haloalkane and solvent our solvent is present in excess quantity so that is not the part of slow step or rate determining step so tale etia kon rahila except solvent haloalkane rahila so rate of reaction is proportional to haloalkane so what is the order of the reaction is 1 okay order of the reaction is 1 tale ethi dekhiba in E2 order of reaction will be 2 how na discuss kariba first जदि हमें SN1 E1 भीतर compare कले then we can also compare between E2 and SN2 we can also compare between E2 and SN2 E2 SN2 भीतर केमती compare करिबा ना both the reactions that is E2 and SN2 are following concerted mechanism that means both the bond formation and dissociation are taking place simultaneously again repeating both the bond formation and dissociation are taking place simultaneously so the name is concerted mechanism okay তাহলে এটি কোন দেখিবা না this is the halogen a living group okay and this is hydrogen so base এটি attack করিব base let's say OH minus is attacking to the hydrogen or its isotope note कर दो attack of base to the hydrogen or its isotope which is anti-coplanar with the halogen. So what is the meaning of anti-coplanar? Anti means opposite side and must be present on the same plane. Okay. So this is the first step. The next one about now this OH starts making bond with hydrogen and the bond between carbon and hydrogen becomes weaker. Dissociation is taking place bond formation is taking place between two carbon atoms, and bond dissociation is taking place between carbon and halogen. So all are taking place simultaneously. So the name is concerted mechanism. Student the bond formation कोठी होची between base and hydrogen. How good formation होची between two carbon atoms. Dissociation कोठी होची carbon hydrogen ଆଉ carbon halogen. Dissociation होची carbon hydrogen and carbon halogen. So all are taking place simultaneously. ସେଥିରେ ଆମେ ତା କଣ କହୁଛେ concerted mechanism. ଆଉ ଆକୁ intermediate ନା କଣ ହେଲା transition state. So finally what will happen? Finally base hydrogen को pick कर नब, then carbon, you can see carbon carbon double bond is formed and halide is released as the leaving group. Halide is released as the leaving group. Note down. Take 2 minutes and quickly note down the steps.